Hi everybody, good morning. Today we're going to be talking about how much energy is actually transferred. Up to this point, we talked about what is endothermic, what is exothermic, what does it mean if heat is absorbed, what does it mean if heat is released. And so now we're going to get into, well, exactly how much energy is actually transferring here. So you're going to need a calculator, you're going to need something to write on, and we're going to take some notes and do some calculations as our example here. So let's get started. Our equation we're going to use is Q is equal to mc delta T. This is an equation that will be given to you. It is a reference tool, so this is an equation you do not have to memorize, even though you probably will. Let's take things apart here so you can see what each thing is. Q is the amount of heat in joules. So when we're talking about Q, we're talking about joules. That's heat energy. We already talked about if it is negative, then it's exothermic, and if it's positive, it's endothermic. For those of you going, wait, where did we talk about this? That's in your foldable. That was in your foldable from this week for you to make. So you remember you are making a foldable. All right, we have mass in our equation, and as you know already, mass is measured in grams. We have our new variable called C. This is called specific heat capacity, and this is our not a system, but a material's ability to gain or lose heat. And if a material has very good ability to conduct heat, then that C, the specific heat capacity, is a very low number. If a material has a very bad ability to conduct heat, then that C is a very high number. The final part of our equation is delta T. This is going to be a change in temperature, and we will always do final minus initial. Okay, so the next thing that we are going to do is we are going to move on to taking a look at an example and discussion here. So let's go on. Exactly, again, what is specific heat? And I want to focus your attention down here to the bottom of the page. So right down here at the very bottom of the page. And what we have here is a comparison of two different materials. We have water and we have gold, both of which are heated by the same amount of heat energy for the same amount of time. In that time, gold heats from 20 degrees Celsius to 90 degrees Celsius. Water only heats from 20 degrees Celsius to a little bit over 20 degrees Celsius. So I would guess maybe 25 degrees Celsius. So water is a not very good conductor of heat, whereas gold is really good. So if we compare their specific heat capacity, gold has a very low specific heat capacity because it transfers heat very well. Water has a very high specific heat capacity because it does not transfer heat well. Okay, let's move ourselves along to remembering what is this, endothermic and exothermic. Please remember, please remember that if heat is being lost by the system, that's going to be exothermic. And if heat is being absorbed by the system, that's going to be endothermic. Okay, and we've talked about how if heat is lost, that is a negative number, and if heat is absorbed, that is a positive number. So the question becomes, what will happen if we have 50 milliliters of water that is cold poured into 50 milliliters of water that is hot? And let's make sure that we know that the cold water is going to be 20 degrees Celsius, and the hot water we're going to pour in is going to be 100 degrees Celsius. Okay? And so we're going to take a look at this from the hot water's point of view. So we're going to be looking at it from the 50 milliliters of hot water as our system. So let's go take a look at those calculations. All right. So how much heat was transferred into the cold water from the hot water? So we want to know what is Q. We have values given to us of specific heat is 4.18, mass is 50 grams, and we need to go ahead and put in that our final temperature comes out to 60 degrees Celsius. And our initial temperature, remember this is of the hot water, our initial temperature is 100 degrees Celsius. So we had a total temperature change of a negative 40 degrees Celsius. In other words, let's think about that. That makes sense. That is that our hot water lost a total of 40 degrees Celsius, so a temperature change of negative 40 degrees Celsius, since it lost that amount of heat. So we are going to calculate Q now. And so for Q, we are going to take the mass, which was 50, and we're going to multiply it by the specific heat capacity, which is 4.18. And we are going to multiply that by the change in temperature, which was negative 40. I'm trying really hard to have good handwriting here. Sorry, everybody, for those of you that are freaking out because it's bad handwriting. Okay, so when we do our math, we're going to put that in our calculator. I got 50, I got times 4.18, and I've got times negative 40, and I get negative 9,600 joules. Okay, if the problem had asked me to solve for this in kilojoules, I would have divided this by 100, so kilojoules would have come out to, and I'm going to quickly write that down. Boy, I'm terrible at this handwriting. Negative 9.6 kilojoules, because I divide my joules by 1,000 to get my kilojoules. So negative 9.6 kilojoules. And then the question is, was this endothermic or exothermic? Because this is negative, it was exothermic. Because this came out negative, it was exothermic. Okay, let's move ourselves along to another example. All right, so then we are taking a look at still another example here. How much heat is required to be absorbed? Key word here. Look at that key word. Heat is going to have to be absorbed. You can already make a determination that if heat is going to be absorbed, then this is going to have to come out to endothermic. That means your Q is going to have to be a positive number. So let's take a look at this. It says raising the temperature of the water, 6 grams of water by 5 degrees Celsius. So since we're raising the temperature, this temperature change is a positive temperature change. And then, of course, we have our specific heat capacity of 4.18. So Q, in this case, is going to come out to 6 times 4.18 times 5. And when we do that math, we end up with 125.4 joules. Okay, and yes, of course, this is endothermic. Okay, so we continue on with a couple more examples. Let's go ahead and take a look at the next one. All right. It says what temperature change occurs if 10 grams of ice at negative 50 degrees Celsius, if 250, boy, that's written wrong. What temperature change occurs if 10 grams of ice at negative 50 degrees Celsius has 250 joules of heat absorbed? Okay, so automatically we can see, oh yeah, we're going to absorb some heat. So we know Q is going to be positive, and we're given the specific heat of ice here. That's important, and we're told joules. So now we want to know grams. So 250 joules means that's Q. And we know this is an initial temperature, Ti. And we know heat is being absorbed, so we know Q is going to come out positive. And we know the specific heat, so that's our C. Now, look at that. I missed something. We also have 10 grams of ice. So we just need to know what temperature change occurs. Okay, so we're going to do this in two parts. The first thing we're going to do is we're going to use Q is equal to M times C times delta T. Okay, and so we're going to plug in our numbers. 250 equals 10 times 2.06 And we are going to solve for delta T. Remember, delta T is the change in temperature. And so we do not actually have to figure out what the first temperature or the last temperature is. We're just asking, well, what is the temperature change? Okay, so to do that, we are going to solve for T, which means delta T is going to be equal to 250 divided by 10 times 2.06 is 20.6. All right. So our change in temperature, using our calculator, 250 divided by 20.6, our change in temperature is a total of 12.1 degrees Celsius. All right. So the change in temperature came out to 12.1, and the question is, will the ice start to melt? Well, let's remind ourselves that the ice starts to melt at 0 degrees Celsius. So now we want to know, well, what is the final temperature? So if delta T is equal to the final temperature minus the initial temperature, and we have the initial temperature from our problem, then we're just going to plug everything in. I am going to change color so you can see it. I have 12.1 for my overall temperature change. I have the final temperature that I want to know, T final, minus the initial temperature, which was negative 50 degrees Celsius. Okay? And I'm going to solve by recognizing that a negative times a negative is a positive, and then I'm going to have to transfer that positive number over to the opposite side. So I'm going to finish up doing 12.1 minus 50 equals negative 37.9. So, will this ice melt? No, it's way too cold. Remember, it melts at 0 degrees Celsius. So this answer is no. This ice will not melt. And is this endothermic or exothermic? Remember, please, that we said that this was absorbed. So this is endothermic. Okay. So next we're going to move on to our final calculation. Oh, was that our last? Actually, that was our last one. Okay, so we're going to have you work on some practice problems on a separate sheet of paper that you will turn in on your own. Thank you, everybody, for listening, and good luck on your practice problems. We can have a tutorial session next week if you would like to go over exactly how to do this, or maybe have some questions answered if you would like some questions answered. Okay, everybody, have a good week.